Thank you for coming here today. Juniper is a sponsor, glad to be a sponsor today of the RISQ Colloquium 2015. We've been a partner with RISQ for many years now, and definitely really appreciate the opportunity today to speak with you about campus LAN evolution and data center evolution to keep pace with transformation in digital education, transformation in research, in communications, and other various technologies. So today we're going to talk about a variety of different architectures. I apologize in advance for starting off the day with a quite technical presentation, but I'll make it hopefully quick and painless. So we're going to look at a variety of different topologies and architectures, discuss some of the pros and cons, and look at some recommendations from the industry. So we'll proceed here. I think I have to go back into presentation mode here. There we go. So let's start by taking a look at some industry trends. So one of the key industry trends that we're seeing a lot, especially in the cloud provider space, is the concept of white box. So white box simply means sourcing equipment, switches, servers, now potentially firewalls and routers, directly from OEM manufacturers overseas, out of China, Taiwan, etc. So the goal there for these very large cloud providers typically is to try and reduce their capital costs and take advantage of, say they build, the big cloud providers like the Googles, the Amazons, the Facebooks, they build applications in-house. They're cloud-based applications. They're designed to be on the cloud, and they can build applications around the network infrastructure. So they can build applications that could take advantage of very low-cost, commodity-based hardware. So they've been pioneers in adopting white box technology. However, for the rest of us, which are deploying off-the-shelf applications, we need a resilient underlay. We need a resilient network to support these applications. So this has been the mainstay of the cloud providers, hasn't really penetrated into enterprise and service provider to a large extent. x86 everywhere. So we constantly hear about virtualization, virtualizing network functions, putting everything into compute. So lots of advantages to doing that. Infinite scale out by adding more servers. You can statistically share different applications in your data center across common compute infrastructure. So a lot of advantages there. Elastic scaling of network function, virtualization. At the end of the day, though, there's still a place for purpose-built hardware. So purpose-built ASICs, pipeline processors, FPGAs that give you additional densities and reduction in power consumption per unit performance, okay? So at the end of the day, a hybrid approach is going to win out. So applications that could take advantage of x86, but as well as underlying infrastructure with purpose-built hardware, okay? Automation is huge. Networking engineers are adopting DevOps-like principles. DevOps is a combination of development and operations. So it's very common in the IT domain, where IT engineers have evolved to leveraging programming skills like Python scripting to automate menial tasks. So if they have to configure hundreds or maybe thousands of servers, they'll write scripts and then run the scripts automatically across all of those servers, okay? So now networking engineers are adopting those DevOps-like principles, bringing scripting capabilities and automation into networking for configuration, troubleshooting, maintenance, service provisioning, etc. People. So a big trend along the lines of what I just discussed. So networking engineers adopting DevOps-like principles. people skills is one of the biggest barriers for transformation of the campus LAN, the data center, et cetera. Having people that have an understanding of both networking knowledge as well as IT knowledge. Typically, you have IT engineers, you have network engineers, it's two different languages. So now we need a new breed of engineer that understands both sides. And I've seen some companies try to force fit organizations together, so they'll actually integrate their network engineers with their IT engineers. And in one case, I've seen them actually interleave the engineers. So if you walk through the aisles there, you'll have a network engineer, then an IT engineer, a network engineer, IT engineer to force those water cooler conversations. Threats. So we all know that threats are pervasive, increasing in complexity more than quantity. So the quality of the attacks is improving. They're becoming more and more organized as part of organized crime. It's no longer just hackers, kids in a basement. And it's a multi-million-dollar industry. You can go online and purchase. You can purchase attacks. You can purchase DDoS attacks online and launch an attack on any website you want. Of course, it's extremely illegal, but it's available there. So the moral of the story is the industry trend is you have to build an infrastructure, and we're going to talk more about this, that can easily adapt to changing threats. So it has to be dynamic. You have to be able to scale up security services as needed, on demand, and put them where you need them in your network. It can no longer be static. And you can no longer assume that just perimeter protection is okay for your network. You have to assume that your network has already been breached, and so you need a whole list of measures and countermeasures to prevent security breaches in your network, including DDoS, intrusion detection prevention, honeypot technologies, cloud-based scrubbing of potential malware, et cetera, et cetera. There's a long list of potential options. And through network function virtualization, as we'll talk about today, that provides a cost-effective mechanism for deploying some of these new security technologies, okay? Because they're no longer dependent on physical devices in the network. So one of the proof points, I'll just build my slide here. One of the proof points in the industry is once again, the cloud providers. So the cloud providers started from scratch. They built their own automation solutions. They adopted DevOps principles day one. They embraced white box. They built their own custom cloud applications. So they're the real pioneers for transformation. So most of the industry is looking at the cloud providers for those proof points. So if we're going to invest in transformation in the network, what are the possible benefits? So some of the proof points here on this slide, for example, operating expenses. Typical large cloud provider like a Google, Amazon, Facebook, et cetera, they have tremendous automation capabilities and operational efficiencies because of that. One admin can support 10,000 servers in a Google environment, but a traditional service provider or large enterprise, the ratio is more like 1 to 100. So 2 orders of magnitude. So there's definitely a lot of room for operational efficiency improvement by adopting some of these automation capabilities. And if you can get it to from 100 to 1 to somewhere like 1,000 to 1, that's a tremendous savings on your bottom line. Time to service deployment, that's really key for the cloud providers. They really pride themselves in the ability to deliver new services very rapidly. So once they've built this transformed architecture, this next generation architecture, they can deploy new services because they're all virtualized, running on generic computing, in a matter of minutes, maybe even seconds, if everything is set up, ready to go. Traditional service providers take 12 to 24 months from service inception to actual delivery. And of course, there's months of planning, new infrastructure, And if you've ever worked with the service providers, typically if you propose a new technology, a new service offering, one of their biggest barriers is their internal IT organization, their OSS, BSS integration requirements. And there's always a magical internal price tag of like $20 million to implement a new service offering. So it's always a roadblock, a bottleneck for a new service introduction. And they claim it'll take them 12 plus months to implement all the OSS infrastructure integration. And if you look at their OSS architecture, it's several pages and it's just completely interconnected, and it's just absolutely it's a real mess. And then operational complexity. Since the over-the-top providers, the big cloud providers, started from scratch, they started with a very streamlined portfolio of products and services. So they have a limited number of SKUs to deal with. And of course, large enterprise, over the decades, service providers, et cetera, have had to deal with decades of legacy. So piling application on top of application, new hardware on top of hardware, OSS systems on top of OSS systems. So what we're going to talk about today is transformation. And the ability to take all of those technologies and consolidate using the latest technologies around that leverage automation and orchestration and other technologies we're going to talk about. So what are some of the challenges today in the campus LAN and data center? So as we know, legacy infrastructure today lacks scalability. It's quite cumbersome to scale today. Predominantly physically based, very limited virtualization in terms of network functions today. Still relies on some legacy protocols like spanning tree, which we'll talk about, which is not a very reliable protocol, not very efficient protocol. Very complex, multiple layers, switches managed independently, limited use of automation technologies, very manual, having to configure each switch independently. Often still a single pane of glass, but you're still managing each switch as a separate entity. And then it's quite error prone. It's quite prone to operator error. If you're programming security policies, you have to make sure that the security policies are disseminated to your entire network. You don't miss any components, create a backdoor into your network. So very cumbersome today, and definitely not able to support your requirements for transformation, to support the new wave of digital learning and the research that's going on in Canada. So with that understanding, what are some of the attributes that we're looking for in the next generation data center and campus LAN network that is capable of transforming into the new era? So full automation, we discussed that. That's a major requirement. Support for virtualization, the ability to support network functions that are no longer required to be in physical hardware. They can now be software running in your servers in your data centers. Location independent workload, that's a really important one. You don't want to restrict yourself so you want to have generic compute in your data center. You want to be able to put any application anywhere you want in your data center without restriction. And the workloads shift over time. The trend we're seeing right now is from a lot of north-south traffic in the data center, exiting the data center, to more of an east-west fabric as we get more distributed applications in the data center through virtualization and local storage and compute. Low oversubscription. I would say actually flexible oversubscription is very important. The ability to have one-to-one oversubscription for high-performance computing in your campuses and data centers, and then all the way up to 6-to-1 or 12-to-1 for best effort services. So you want the ability to maximize the economies of the infrastructure by suiting the applications to different oversubscription ratios. So you need that flexibility in your campus LAN and your data center. Any-to-any connectivity, the ability to connect all the different Ethernet speeds from 1 gig up to 400 gig is not too far around the corner, including legacy fiber channel over Ethernet, maybe InfiniBand if you have it. Simplified and efficient orchestration. We need one pane of glass, the ability to manage the entire network, end-to-end, point and click. And then multipath. We're going to discuss the different fabrics. Multipathing is very important to maintain efficiencies in the network. Legacy spanning tree only utilizes half the resources in your network at any one point in time. So multipathing technologies allow you to load share across your entire infrastructure. So here's some of the different topologies we're going to talk about today. So layer 2 multipathing. So we have spanning tree legacy. It's, as I mentioned earlier, it's has very large failure domains. It's one of the big issues with spanning tree. A simple misconfiguration, a software bug, a hardware failure can bring down an entire campus LAN or data center that's running spanning tree. And it's very inefficient. It's active standby, so it shuts down half of the network to prevent loops. So a lot of the vendors, Juniper included, have invested a lot in some of them, proprietary, all based on low-level standards, but in the end, the implementations are usually proprietary, lacking interoperability. These are solutions that fix some of the spanning tree problems. So they solve the multipathing problem. They allow efficient load distribution across a fabric in your campus and your data center. And at the same time, so they solve the multipathing problem, they solve the failure domain problem, they solve the efficiency problem. And there's different technologies out there. The virtual chassis, which Juniper has, and in our solution suite, I'll talk a bit about that. Multi-chassis lag, it's been around a while. SPB, short path bridging. Juniper had QFabric. Trill has been pushed. Trill has been advocated as a standard, but like a lot of the other technologies, the reality is there's limited interoperability between vendors because of the various, the implementations of the standard. Some of them go down to the basic, to layer 1, layer 2 encapsulation technologies being used. And then there's IP fabric. So IP fabric is really catching on. Well, I shouldn't say catching on. It is the most popular solution with the cloud providers. They do it for scalability, infinite scalability, flexibility in architecture. You can have any architecture you want. They do it for cost efficiencies because you can leverage small building blocks to build an IP fabric. So you can leverage top-of-rack switches, which have huge economies of scale, with off-the-shelf switching technology like the Broadcom Trident 2, which is very common in top-of-rack switches. So you leverage that huge economies of scale that comes from the pricing pressures of top-of-rack switches, and you can build a multi-layered hierarchy with these building blocks. And what that does is allows you to build a very, very scalable fabric at very, very low cost. So this is what the big cloud providers, and the cloud providers, they buy, like Amazon, they buy like tens of thousands of switches, not tens or hundreds, tens of thousands of switches to build these architectures. So they're very, very cost sensitive. So IP fabric, instead of trying to recreate multipathing at layer 2 using what ends up being proprietary implementations largely, with IP fabric, we use standard-based technology that's been tried, tested, hardened. It's what runs the internet. So technologies like BGP, ECMP, equal cost multipath routing have been around for a long time, tried, tested, stable, very scalable. And that provides the multipathing capability to efficiently share the resources in your campus LAN and data center, okay? So it's complete vendor interoperability, low cost, very scalable. So very, very popular with the cloud providers, and now the service providers are all focused on IP fabric for transformation of their data centers. So that's the next wave of transformation in the data centers. Everybody's going to IP fabric. And then once you have that IP fabric, the third scenario on the right is you can introduce overlays over that fabric with SDN control. And the primary purpose of that is because the SDN controller, and I'll talk a bit more about that, is deeply integrated into that IT orchestration environment. So it's integrated into your VMware, your OpenStack, Cloud Stack, whatever orchestration environment you might have. So when your IT organization does moves, adds, changes, those changes are automatically propagated to the network, and the network updates in real time. So the days of an IT engineer telling the networking team, hey, I'm gonna change around some virtual machines. I need you to reflect that in the IP addressing plan. And a few weeks later, they simultaneously move the stuff over. Now it can be done in real time through a single interface. And the network and the IT resources are updated in a synchronous fashion in real time. Okay? So multi-tier Ethernet, so one of the basic versions of multi-tier Ethernet is, so you have a spine layer at the top and a leaf layer at the bottom, and you simply use a technology called multi-chassis lag. So lag, link access group technology, which essentially load shares into a pair of redundant routers in the spine. So this is quite widely deployed. Avoid spanning tree and all the issues of spanning tree. It's good for smaller deployments. And then we talked about Ethernet fabrics, some of the proprietary fabrics. Once again, they get rid of spanning tree. They solve the efficiency problem. They solve the failure domain problem. Fully redundant architecture can provide both layer 2 and layer 3, can provide scalability up to medium to large data centers and campus LANs. The only drawback of this is they're largely proprietary, based on underlying standards, but the implementation itself is usually proprietary from every vendor. IP fabrics, mention that one more time. So de facto for cloud providers, service providers are transforming in this direction. Lowest cost, most interoperable, leverages underlying technologies, and very flexible. One caveat to this is, in contrast to the previous solutions, so the Ethernet fabric solutions are designed to operate as a single entity. So it looks like a single virtual switch in your campus LAN or data center. IP fabrics, each of the switches or routers in your backbone look like independent switches, so they're managed independently. So what Juniper has done is we've created an open source set of scripts, Python scripts, a Python script library. It's available on GitHub, which your teams can freely download and use. And it facilitates the automated configuration and maintenance of complex IP fabrics. And you can update the scripts, you can change the topologies at will, you can add different vendors' products into this solution, the OpenCloth solution on GitHub. So it helps close that gap between IP fabrics and the cohesive single switch Ethernet fabrics. Okay? And then we talked about overlays. So one technology for introducing overlays is SDN. So independent of your data center fabric, if you have 10-year-old, 20-year-old fabric in your campus LAN or your data center, you can run SDN on top of it because it is agnostic to the underlying switching layer. Because what it does is it creates end-to-end overlay tunnels across your campus LAN or data center that connect virtual machines to virtual machines, okay, or virtual machines to your WAN gateways in your network. So you can modernize an existing deployment without having to forklift your underlying fabric. That is possible using overlay technologies. So another overlay technology that is gaining momentum, and perhaps a precursor to SDN for a lot of customers, because they're not quite comfortable with SDN yet, is a technology called EVPN, or Ethernet VPN. So there's the capability of deploying this Ethernet VPN as a controllerless SDN in your campus LAN or data center, and that provides, once again, that overlay that's independent of the underlay, and that uses just standard VXLAN technology for the tunneling. Okay, so a couple different overlay technologies that give you that integration into your IT environment, right? And as well, they don't force you to forklift the underlying switching fabric in your campus LAN and data center. So two key benefits there as an alternative to forklifting all of your fabric. And now there's investigation into extending MPLS into the campus LAN and data center. So a traditional data center has a large router at the edge of the data center, a data center edge router, and it acts as a provider edge router. So it connects a data center to the wide area network. Okay, so it has a lot of functions that bridge an MPLS-based wide area network to a data center based on any of the four fabrics we talked about. So with the potential for MPLS in the data center, what we can do is diminish and potentially eliminate that large router at the top of your data center. So have seamless connectivity across your wide area network, right into your data center, and right up to your top of rack switches or your servers, in fact. And there's been a lot of investigation into new MPLS control layers. So in addition to RSVP and LDP, also a lot of investigation into a new protocol called Spring or segment routing, which is essentially a source-based routing. So the source host, either the top of rack switch or the server, determines the route through the data center or campus LAN. So that's emerging standards. There's some pioneers. Once again, the cloud providers are the real pioneers here. Like Facebook is really pushing this. Microsoft, I think, is engaged as well. So, but keep an eye on this. It may become mainstay in a few years. So my shameless sales pitch. So we talked about the different fabrics. Ideally, you want a common set of building blocks that can allow you to flexibly choose the different fabric technologies, be able to mix and match. It doesn't have to be one or the other. You can actually mix and match depending on your requirements. You can combine the different fabric technologies. And also you want to be able to evolve over the future. Maybe you want to start with a layer 2 fabric and evolve to an SDN overlay. So you want to be able to have that flexibility and the future-proof potential of being able to transform to the latest and greatest, and potentially SDN down the road as well. So the Juniper switching solution, we support a variety of SDN protocols. So VMware, of course, we support. We support OpenStack. Mesosphere is another one. CloudStack. So we're adding more and more controllers to our switching solution. That's important because a lot of people view in the future there's going to be multiple SDN domains. SDN controllers are going to be used for specific applications, and you're going to want to be able to integrate a multi-SDN network. I'm talking a few years out here still, but that's the projection of the future. And then there's going to be either east-west mediation of controllers, or controller of controllers, or orchestration. That's not well defined yet. People are still focused on introducing their first SDN controller today. And of course, automation. Automation is extremely important. So we've integrated the DevOps tools from IT, like popular tools like Puppet and Chef and Ansible, and native Python scripting and all of our switches. So you can leverage those automation tools in the networking domain, and they're not just confined to compute and storage. So one of the solutions that Juniper has created for campus LAN and data centers called Junos Fusion. So this is an Ethernet fabric solution. It uses an underlying standard called 802.1br and virtual chassis, and it gives you a highly resilient, a single logical switch environment for your entire campus LAN. Very scalable, scales up to 6,000 ports, which would be up to 6,000 wiring closets in a campus. So very, very scalable, cost-effective, single pane of glass management, et cetera, et cetera. And then the building blocks, once again, can be reused in any of the other fabric choices, the other technologies, should you want to change, or it can be combined with some of the other fabric technologies. And then part of the bigger picture, so we've taken Junos Fusion and embedded it into a more complete solution for academia and large enterprise. So starting at the bottom, the foundational technologies, Juniper, silicon, off-the-shelf silicon, we talked about Junos Fusion, network infrastructure, servers, routers, switches. Our key partners, Microsoft and Ruckus for Wi-Fi. Microsoft has certified Juniper switches for use in Office 360 applications, and then a whole catalog of security applications as well. And just running out of time here, so I just wanted to summarize the automation. Since automation is so important, and it's the foundation of transformation. So we talked about platform automation. So there's three levels of automation, right? There's the platform, which is the underlying components, right? So we talked about leveraging DevOps-like technologies for automation of networking, Puppet, Chef, Ansible, native Python on our switches, so you can run scripts to do routine tasks. Network automation, SDN provides a network level automation, looks at the network as a cohesive whole, integrates into the domain level above that, which is your compute and storage orchestration as well. So compute, storage, network, orchestrated as one end-to-end entity. So the automation is really the key for transformation in the future to reducing the operational reducing the operational overhead, increasing the efficiencies, and potentially getting those operational metrics, from 10 to 1 to, perhaps 100 to 1, 1,000 to 1 and beyond. So I thank you for your time.